So look at that picture, and the goal is to figure out what fraction of that picture is actually black. Not gray, not white, but actually black. Okay. We're going to talk about that later, and we'll try and use some math to actually back up our answer. So since we're talking about geometric sequences, we've got 6 boxes to cover for today. Let's start off by talking about, whoa, where'd it go? Let's start off by talking about a definition for ourselves. So, the first idea. So we're going to define what a geometric sequence is. Okay, a geometric sequence. For us, it's going to be a sequence with a common ratio. So, like arithmetic sequences, there is this pattern between the terms in the sequence. This one's going to have a common ratio. We're going to call that ratio R. And it's important to note that the ratio is not allowed to be 0. If it was 0, then we'd have dividing by a 0 there. It wouldn't be any good. So how do we come up with this ratio? What do we do for the difference? What do we do between the two terms? We just kept adding on that difference, right? So in this case, what are we going to do? Instead of adding, we're going to actually multiply the two differences, okay? So let me give you an example of one, and we're going to write the first 4 terms. All right, so let's say that a sub 1 is equal to 4, and the common ratio here is equal to 3. What does this look like? If this is a geometric sequence, well, let's make some room for our first 4 terms. We got 1, 2, 3, 4. A sub 1, A sub 2, A sub 3, A sub 4. Okay, the very first term was given to us is 4, common ratio, yeah, R. So the very first term is 4. So how do we get the next one? Well, the number, whatever a sub 2 is, when I divide it by 4, that ratio has to be 3. So what number divided by 4 would give me a 3? 12, yeah. So what's the other way of thinking about that? What number do you have to multiply by 4 to get 4 times 3? Yeah, so what's the next term? 36. Yeah, very good. What's the next term after that? 108. Good. So notice, this is definitely not arithmetic anymore, right? We're definitely not adding the same number, and the difference between the two consecutive terms is not the same. But in this case, if you pick any term, let's say I pick the third term, 36, and divide it by the previous term, 12, I would get that value of 3. Pick any other term, 108, divided by the previous term, 108, divided by 36, again, I'd get a value of 3. So the commonality here is the ratio of the two terms, no longer the difference of the two terms. That's what separates geometric from arithmetic. Okay, let me give you a recursive one, and you guys write it out. Let me give you a sub 1 is equal to negative 2, and a sub n is equal to negative 6 times a sub n minus 1. Let's write out the first 4 terms. 1, 2, 3, 4. Now this is recursive because geometric sequences, just like arithmetic, are recursive. So that's the very first term of the sequence we have. Negative 2. Awesome. Okay. What does this mean? You have to be able to look at that and understand what that means. So in plain English, what does that mean? Yeah, the next term is negative 6 times the term before it. Exactly. So what is negative 6 times a negative 2? 12. A positive 12. Good. What is the negative 6 times a positive 12? Negative 72. What is the negative 6 times the negative 72? Positive 432. Awesome. So now that we know this, could we figure out what the ratio is? Or just take 12 and divide it by negative 2, and we get a negative 6 for our ratio, right? Okay, let me show you how this works on the calculator. So, bust it out. And we can actually write these. Whoops. Oh, it's going to work out here. The ratio is negative 6. Because 12 divided by negative 2 is negative 6. And then negative 72 divided by positive 12 is still negative 6, right? Does that make sense? Yeah, I just wrote 6. Oh, I did? For some reason, I can't get rid of this now. Here, I'll get rid of that. Oh, thanks. Negative. It's a negative 6. Okay, so let me show you how to do this on the calculator. Apply for this. So how do we plug in the sequence for this, right? So we're going to do the the first term is -6, right? So we'll do a -6. And then we're going to multiply the ratio by, oh wait, you know what? I'm going to show you this after I do the next one. Put this one away for a second. Let me show you how to do this, get the fast forward formula first. And then we'll come back to that. Am I on the third? Yeah, okay. So just like arithmetic sequences, the geometric sequence also has a fast forward formula. And it's also known as the general term formula. So you might see that as well. So fast forward in general terms. So let's do a conceptual thing for you here. So let's say my very first term of a geometric sequence is a sub 1, whatever it happens to be, right? Okay, then the next term is going to be a sub 1 multiplied by what? By the ratio. Awesome, right? And that ratio would be to the first power. I have one of those, right? The next term would be the very first term multiplied by how many ratios down the line have I applied? 2. So that would be r to the second, right? So if I kept going, so if this is the first term, and this is the second term, and this is the third term, the question is, how do I write then the a sub nth term, right? Well, it would be the very first term that we have multiplied by the ratio, but what's the connection here between this input here and this ratio value here? This input here, oh, that should be a 3, thanks. This would be a 3, and this ratio value up here. It's less by 1. So could I even write an r to the 0 power there, and would it still work? Be true? Yeah, it would, right? This is my input value, and this is my less than 1. So then it would be a sub 1 times the ratio to what exponent?
N minus 1.
You got it, n minus 1. Awesome. So this is our very first major concept for geometric sequences. Any old term, a sub n, is going to be represented by the very first term, a sub 1, multiplied by the ratio to the exponent of n minus 1. So I wanted to show you why that n minus 1 was there. Okay, sorry, I should show you that. So we can use our calculator, and we can use this general term formula to get this sequence, -2, 12, -72, 432. So I plugged in the sequence. I plugged in the very first term, which was -2, our ratio of -6 to the power of x minus 1. That's our general term sequence. Our variable was x. We started at 1. We went to the first 4 terms and went by 1s. And notice that the calculator gave us the same exact sequence that we got from when we did it ourselves. You guys on board with that? So it's an easy way to check to make sure you're doing it right and plugging in the right sequence. Just make sure you put parentheses in your exponents if you don't have one of those fancy calculators that automatically moves it up there for you. Okay, you guys on board with that part?
How can we calculate it?
So the first term is going to be 5. So a sub 1 is a term of 5. What would the second term be, just for the heck of it, just talking about it? What would the second term be if the ratio is 3? 15, yeah, very good. Okay, good. So I want to be able to skip up to the 8th term, all right? So using my, my general term here, I'm going to do that a sub 8 has to be the very first term, which is 5, multiplied by the ratio of 3 to the exponent of 7, because I'm going to do n minus 1 of whatever term I'm looking for. All right, so we'll do 3 to the 7th, and then multiply by 5. So 3 caret 7. Enter, then multiply by 5. So the 8th term of this thing, is that what you guys got too?
Yeah.
2. I got something totally different. No.
What's A3? What do you have for A3?
The third term?
Yeah, like what do you multiply?
Oh, I'm multiplying this term. Yeah, the previous term.
5
So
by 3 and then NFOD multiplies 15 by 3 again.
by 3 again. Yeah, I get 45.
So it's all by 3.
Yeah, the ratio is 3. Okay. So I want to go to the calc. I got something different last time. Did you guys get the same thing?
Mm-hmm.
So I got 3 to the 7th. Equals that. And then finally multiply that by 5. All right. So there we go. Did you guys get that? That's what I got too. $10,935.
Yeah.
You guys go with that part? All right. All right. Let me give you another one. Okay. If the very first term is 1,000, okay, and the common ratio is -1/2, write out the first 2 or 3 terms, and then skip up to the 40th term, and tell me what you get. And you're going to need your calculator for this one, and I want to show you the notation on the calculator, what you're going to experience. So write out the first 2 or 3 terms. We'll do the first one we know is 1,000. And so if the ratio is negative 1/2, then what does the second term have to be? Negative 500. Very good. Okay. If the ratio is negative 1/2, again, what does the third term have to be? Is it positive or negative? Positive 250. Yeah. All right, good. So here's a sub 1, here's a sub 2, here's a sub 3. Could you then skip up to a sub 40? Do you guys think it's going to be a big number or a small number? This is going to be a really small number. 40 terms all the way out there? All right, good. See what you come up with, and we'll talk about what the calculator says. All right, make sure you're plugging in right. Here's what I did, right? I took 0.5, and oh, shoot, negative 0.5. Sorry, you get the same answer, though. Yeah. Here you go. Here's what you want to do. Negative 0.5, and you want to raise that to the power of 39, right? Why is the power of 39? And minus 1. Good. Push enter. Then multiply by 1,000, your very first term. And I'm getting this. What does this mean? What does that mean? Is that a big number or a small number? Well, that's a super small number. So when you see an E on your calculator, that means a times 10. That is a scientific notation expression. So this is going to be negative 1.82 times 10 to the negative 9th. So 1.82 times 10 to the negative 9th. That is a very, very, very small number, which makes sense because we're decreasing by half very quickly, and we're going all the way out to 40 terms for that.
We ever have to.
Okay, so we have these 2 sequences here, and these sequences are geometric. So let's figure out the first term, the ratio, and then we'll write a general term formula for it. So a sub 1 is going to be 3. What's my ratio for my first sequence there? If I go 3, 12, 48, what do you think?
4.
Yeah, the ratio is definitely 4. So we know this. We know that a sub n is equal to a sub 1 multiplied by the ratio n minus 1. So therefore, a sub n has to be 3 times the ratio, which happens to be a 4, all to the expression of n minus 1. So that is what we mean by write a general term for the sequence given.
Oh, but for that n minus 1,
Hmm?
you're referring, is that literally like you're actually plugging in like an n value? It's not the term before.
Yeah, that's an actual n value. So let me explain. Like, as an example, if I plugged in a sub 3 to this formula, I'd have to do this. 3 times a 4 times,
3 minus 1.
which would be what? 2. So if I keep going, this is going to be 3 times 16. What is 3 times 16? Well, it better be 48 because that's what it says right there. You got it? You guys make sense? Okay, let's try this one. It better be 48. There you go. Okay, so a sub 1 is going to be 12. What's our ratio for our second sequence here? 1/2. Awesome, you guys are totally getting this. So therefore, a sub n is equal to the first term, which is 12, multiplied by the ratio of 1/2 to the n minus 1, and we're all good. So just like arithmetic sequences, we can add up the first however many in the sequence. We can do the same thing for geometric. So the sum of the first n terms of a finite geometric sequence is going to be the very first term multiplied by 1 minus the ratio to the exponent of n divided by 1 minus the ratio. So next big idea. Let me tell you what all the pieces mean here. So what does this s sub n mean? What does that n down there mean?
The sum of the number that you're looking
Yeah, the number of terms, right? The sum of the number of terms. So this n and this n, those are going to match. You guys cool with that part? Yeah? Okay. What does a sub 1 mean? The first term, whatever that happens to be. Okay? And what does r mean? That's your ratio. Okay? So this is the formula we're going to have to use to find the sum of a first n terms of a geometric sequence. So as an example for you, let's try this. Let's do 2, 6, 18, 54, yada, yada, yada. Let's find the sum of the first 12 of those. Well, first of all, is that sequence geometric?
Yeah.
It is. And what's our ratio? 3. Awesome. So the sum of the first 12 terms has to be The very first term is 2. Multiplied by 1 minus our ratio, which you guys told me was 3, which is correct, to the power of 12, all divided by 1 minus 3. So let me show you how to successfully plug that into the calculator, because that's the hardest part. Here's what you need to do in order to get the right answer out of this. Clear your screen, make sure it's nice and clean for you. So I'm going to do 3 to the 12th first. I'm going to go 3 caret 12. Follow along with me here, so make sure you do the same thing. Then I'm going to take that answer, and I want to do 1 minus whatever that value was. Here's how you do it in the calculator. Go 1, subtract, and then hit second answer, which is right next to the enter button down below. By doing that, that gives you the numerator, 1 minus 3 to the 12th. Then we're going to divide that by what value on the denominator, guys? -2. Awesome. -2. Push enter. And then lastly, multiply that whole number by what's the number on the outside. There you go. So the correct sum of this finite geometric sequence up until 12 is 531,440. 531,440. All right. Try this one when you're done. 4, -12, 36, -108, and we'll do the sum of the first 11 terms.
177,000.
Has to be, the sum of the first 11 terms is going to be the first term, which is 4 multiplied by 1 minus, the ratio is -3 to the 11th, all over 1 minus -3. Okay? Here's how you plug in the calculator really quickly and make sure you do it right.
I see.
You're going to do,
I think I simplified
you're going to do a -3 to the 11th power. Push enter. 1 minus second answer divided by 4. And then finally times 4. And you end up with 177,148. 177,148.